Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 3, and today we're looking at Section 3.4, which is working with grouped data. So we're going to talk about how to find the mean, variance, and standard deviation from a grouped frequency distribution. So suppose your data has already been summarized by a frequency distribution, and I mean a frequency distribution with classes. So in that case, the individual data values would no longer be shown. You would only be able to see the classes. So in the example we're going to be looking at, the classes are 1 to 5, 5 to 9, 9 to 13, like that. So you only have the group data available. So to estimate the average or the mean from this frequency distribution, you would find the midpoint for each group. The midpoint is the halfway point in each group. So to find that midpoint, you just average the class limits together. And you'll see an example coming right up here. And then use the midpoint as a representative value for that group. And then once you have that midpoint, you just calculate the mean, like we talked about back in section 3.1, as a weighted mean. So let's look at the formula first. So the formula for the sample mean from group data is X bar is approximately the sum of each frequency times its midpoint. So the class frequency times the class midpoint, you calculate that product for each class and then add all of those products together. And then once you've done that, you just divide that sum by the size of the sample, which is n. So again, f sub I is the frequency for class I. M sub I is the midpoint for class I. N is the number of observations, and you can get that by adding all the frequencies together. K is the number of classes. Now we're getting a little fancy with our notation here. But remember that the mean is only an approximate value since the midpoint is just an estimate of the value in each class. So hopefully it's a pretty decent estimate, but really it's the best you can do when you have group data. If you happen to be working with a population, it works exactly the same. Just two little pieces of notation are different. Remember, the population mean is always called mu, and the population size is always called capital N. All right, so here's our example. An online merchant has collected the following group data for the number of web pages viewed by a sample of its customers. So 6 customers viewed 1 to 5 pages, 12 customers viewed 5 to 9, 10 customers viewed 9 to 13, and 4 customers viewed 13 to 17 web pages. The merchant would like to calculate the average number of viewed pages. So I'm going to show this to you 2 different ways because I don't think that this is necessarily the clearest way. So first of all, these midpoints. The midpoint for the first class is 3, and that's because the limits of that class are 1 to 5. So you just take the average of 1 and 5. 1 plus 5 is 6. 6 divided by 2 is 3. So that's how they got the 3 here. Same thing for the class 5 to 9. 5 plus 9 is 14. 14 divided by 2 is 7. So now you have this nice table. And so again, I think that there is a clearer way to do it, which I will show you on the next slide. What you do is you take each frequency times its midpoint. So that's how they got 6 times 3, 12 times 7, 10 times 11, 4 times 15. You add all those products together, and it comes out to 272. And then to find the size of the sample, just add these frequencies together. If there were this many customers that viewed 1 to 5 web pages and this many that viewed 5 to 9, et cetera, then there must be a total of 32 customers in this sample. So the mean for this sample, and again, this is an approximation, is 8.5 web pages. The average number of viewed pages is about 8.5. So what I recommend you do is make a table. So here is the same table that we had on the previous slide. And then what I like to do is add another column to my table where I actually write down all of those products. So 6 times 3 is 18, 7 times 12 is 84, 11 times 10 is 110, 15 times 4 is 60. And when you add all these values together, you get 272, just like you saw on the previous slide. All right, so hopefully that'll make it a little easier for you to calculate this or to estimate this mean. Now, I don't believe that we ever talked about finding the variance from a frequency distribution. The logical time to talk about that would have been in section 3.2, so they were, I guess, saving it for this section. Now, this is another formula that looks kind of intimidating. I just want to point out it's basically almost the same formula that we used back in section 3.2. It's just that the x has been replaced with a midpoint. Remember, we're using the midpoint to approximate each value. And then you have to weight that number by multiplying by its frequency, okay? All right, and again, I'm going to do this in the form of a table. This table is going to have several columns. And again, X bar is the approximate sample mean, F sub I is the frequency for class I, M sub I is the midpoint for class I, just like we were talking about a minute ago. And then N is the total number of observations, K is the number of classes. One big difference, and this is consistent with what we said in section 3.2, if you're working with a population, instead of dividing by the sample size minus 1, you divide by the population size and you don't minus 1, all right? And then the difference in notation, sample variance is always S squared, population variance is always sigma squared. All right, so here's the same table that we were just looking at. And again, I think that there is a clearer way to do this, which I will show you on the next slide. So they want us to calculate the variance and standard deviation. So first of all, recall that the sample mean was actually approximately 8.5. So what you have to do is subtract the 8.5 from each midpoint, square that difference, and then multiply it by the frequency and add all of those together and then divide by the sample size minus 1, all right? I think it's going to be a lot clearer on the next slide, so I'm going to save most of my energy for showing you that one. It comes out to 440 divided by 31, which is about 14.194. The good news is that the standard deviation is exactly the same thing that we did in section 3.2. It's just the square root of the variance. So the square root of 14.194 is about 3.767. And if you're doing online homework, just pay attention to how they want you to round those answers. Okay, so here's the table I made. And I used Excel to make this. This part here is exactly what we already had from when we did the mean. So what I would recommend you do is just keep that same table and add some more columns to it. So the first column is called M sub I minus X bar. I'm sorry that doesn't look pretty, but it's just too hard to write those formulas correctly in Excel. So how I got this negative 5.5 was I went 3 minus 8.5. Remember, 8.5 was the approximate sample mean. So 3 minus 8.5 is negative 5.5. 7 minus 8.5 is negative 1.5. 11 minus 8.5 is 2.5. 15 minus 8.5 is 6.5. Now, I want to caution you about something that trips up a lot of students. I think I mentioned in section 3.2 that when you make that x minus x bar column, those values are supposed to add up to 0. That does not work when you're working from a frequency distribution. You should not expect these values to add up to 0, okay? All right, and then the next thing I'm going to do is I'm going to take all those differences and square them. Remember that when you square a number, you will never get a negative. So I don't have any negative numbers in this column. The square of negative 5.5 is positive 30.25. The square of negative 1.5 is positive 2.25, et cetera, et cetera. And then finally, you have to multiply each of these numbers by the frequency for that class. So 6 times 30.25 is 181.5. 12 times 2.25 is 27. 10 times 6.25 is 62.5. And finally, 4 times 42.25 is 169. And when you add these numbers together, you get the 440 that you saw on the previous slide. And then just divide that by the sample size minus 1. And that will give you your sample variance, or I should say your approximate sample variance is 14.194. I didn't include the standard deviation because that works the same way. It's just the square root of the variance. And that is going to do it for section 3.4. We'll see you next time.